Hey, geometry, welcome to Unit 2, which matches up with Chapter 3 from the book that this is based on. Unit 2 is going to be, or Chapter 3, is going to be on parallel and perpendicular lines. So parallel and perpendicular, a lot of different applications of it. Parallel being that they kind of go right alongside each other, perpendicular intersecting at 90 degrees. So before we get to all that stuff, we have some lines and transversals is what we're going to start with in this first section, so 3.1. So the goal by this one is that you can identify angle pairs formed by lines and transversals. So what is a transversal? So a transversal is a line that intersects two coplanar lines at two distinct points, or two different points. Two different points. So if I have two lines, they could be parallel, they could or not. They could be, otherwise. So I have a couple lines. If I have another line going across them, it is kind of traversing across. That is our transversal. So this line here is our transversal. All right, and you'll see as we look down the page, I got our transversal here, and then we got our line here. This is our transversal on that one. All right, so when we do that, we create a whole bunch of angles, and we have a bunch of names for these angles. So corresponding angles are angles that are in the same relative position. With regards to like the transversal and the intersecting line. So this is kind of best given with an example. So for example, i.e., if we look down here at this picture, if we look at angles 1 and 5, those are corresponding because they're both kind of to the top left here. They're on the left side of this transversal, and they're both, and it's kind of on the same side of each of these lines that it's traversing. So 1 and 5, angle 1 and angle 5 would be corresponding, or corresponding angles. We could also say angle 2 and angle 6 are corresponding. Angle 2 and angle 6. And hopefully you can kind of spot and maybe predict these. 3 is corresponding with 7. Angles 3 and angle 7. We would call those corresponding angles. And then 4 corresponds with 8. And angle 4 goes with angle 8. All right, so those would be all of our corresponding angles from this. All right, so alternate interior angles are non-adjacent angles. So adjacent angles, so they share a ray, the same vertex and the same ray. So the non-adjacent that are inside the two lines. So we want to be, this is the interior, right? So these are my two lines. Here's my transversal. So they need to be, if it's alternate interior angles, so it's on the interior, on the inside of the two lines, not adjacent, so like not 5 and 6, but and then so on the inside of the two lines and on opposite sides of the transversal, and on opposite sides of the transversal. All right, so for example, like this, we could say, if we looked at this graph, angles 3 and 6 are alternate interior angles. They're on the interior and they're on alternating sides of the transversal. So angles 3 and angle 6, or we could say 4 and 5. Or angles 4 and angle 5. All right, and those are pairs of angles. So we're still looking at pairs of angles when we do this. So those would be alternate interior angles. Alternate exterior angles, you might be able to guess. Non-adjacent, adjacent angles that are outside the two lines. and on opposite sides of the transversal again, and on opposite sides of the transversal. So we want the outside this time, so we're talking about 1, 2, 7, and 8, non-adjacent, so not 7 and 8, but 7 and then the one on the opposite side of the transversal here, 7 and 2, or 1 and 8. So for example, angles 1 and 8 are alternate exterior angles, and 2 and 7. 2 and 7 are alternate exterior angles. They're on the exterior of those two lines that are being traversed, and they are alternate. They're on opposite sides of this transversal. And then we'll look at properties related to these later, but we just want to make sure we can identify these now. All right, so then we have consecutive interior angles, also known as same side interior. Same side interior. So not alternate interior, but same side interior or consecutive interior angles. And so these are interior angles. So they're on the inside that are, so they're inside the two lines and on the same side as of the transversal. Of the transversal. So let's see if you can predict our consecutive interior angles. So we could say angle 3 on the same side of it and on the interior, and 5. So for example, angle 3 and angle 5, or angles 4 and 6, angle 4 and angle 6. Those would be same side interior angles. All right, so let's see if we can identify all the angle pairs from the diagram. So I got the diagram here. Move myself. So maybe pause and see if you can identify all of these. But our corresponding angles, I'm going to kind of just shorthand this. Our corresponding angles would be 1 and 5. I'm not writing out the full notation. I'm just kind of writing them out there. So 1 and 5 would be corresponding. 2 corresponds with 6. 3 corresponds with 7. And 4 corresponds with 8. Those are all the corresponding pairs. And you can say in either order. 5 corresponds with 1. That's fine if you say it in the reverse order. Alternate interior angles. We have a couple of pairs here. So we could say 3 as alternate interior with 5. And 4 is alternate interior with 6. Again, this is not the proper notation. You probably just want to write out the angles like I have up here, but I'm just going to do it in a quick shorthand. Alternate exterior angles. So we would say angle 1 is alternate exterior with 7, and 2 is alternate exterior with 8. And then consecutive interior angles, or same side interior, would be 3 and 6, and 4 and 5. Those are on the same side of the transversal, and they're interior. So those would be our angle pairs for that set. So that is the start of it. We'll get to some properties of that in the next video.